Hello, everyone. Um, Hi, Yvonne. Thank you so much for making it to today's program. I will just introduce WiMLDS a bit. So WiMLDS is an organization that's worldwide, and we have several other sections or chapters in other countries. And our mission is to support and promote women and gender minorities who are practicing, studying, or are interested in the fields of machine learning and data science. And today we are so glad to have Yvonne join us. Yvonne, could you please introduce yourself to us?
Hi, we'll put my camera on. So my name is Yvonne. It's a pleasure being here. Where do I start with my introduction? Okay, Yvonne Wambui, I'm from Kenya. Although most of the time I spend it in Kigali. I have a master's in master's in IT, concentration in data science, and from Carnegie Mellon University. Before doing my master's, I was in I'll say the finance industry. I did my bachelor's in business information technology. So what I was doing is development of what here in East Africa we call agency banking. I guess it's also there. So we're doing payment gateways over there. So transitioning into data science. And then I co-founded Hepta Analytics with a couple of my friends who Hepta Analytics basically is taking the helping small and medium-sized enterprises to make use of their data. And when we left Carnegie Mellon, we had this idea, we had all these skills that we had, and we wanted to apply it, but we realized that the SMEs in Africa are not ready for it. So we had to take them through the journey of being prepared for the data science and everything. So I did it in 3 steps. So the first one is work on your infrastructure. How good is your infrastructure? Then the second one is now doing the data analysis, the data science stuff. And finally, we do the serving. So in a nutshell, that's it. I've been in the industry for how long? 2013? Yeah. So yeah, but I keep switching. The data science in Africa is still in the early days. So yeah. Yeah, in a nutshell, that is me.
Yeah, that's a very long time actually. 2013, I'm not sure I even knew about AI or data science or anything. You definitely have a lot of experience. So I would give you the floor to talk about.
Yeah. Yes, so let me share my screen. I've been trying to figure out this. I think it is here. Let me see what you are saying. Okay, great. So when I was told to talk about the landscape in AI tools, it was really, I kept asking myself, what exactly is this and how do I approach it? And given that I'm in production, meaning in the industry area, I will talk about it from the industry side and not from the academia. Although the way I look at it is that there is a gap between those people who are in academia and those people who are in industry. And that gap, there needs to be somewhere in the middle, some people in the middle to actually bridge that gap. So yeah, and then you can interrupt me anytime if you have any questions. So I will start. So the agenda is I will start with what is AI, then I will go to what we call MLOps architecture. Then I will talk about the factors to consider when choosing a tool. Then finally, I will dig deep into the tools in the different categories, and then I'll be open for questions. So there are very many descriptions of AI depending on who you're talking to. And these are just a few from the leaders in the industry. Microsoft talking about the ability of computer systems to make human-like cognitive functions. AWS is a field of computer science dedicated to solving cognitive problems. And then IBM is leveraging computers and machines to mimic the problem solving and decision making with the human mind. But all in all, everything summarizes to it's a computer system with cognitive functions, and it's solving a problem. So those are just the three steps. Then there is the narrow AI and there's the general AI. So the narrow AI is for specific tasks. The computer system is actually solving a very specific task. It can be recognizing cats. It can be something like a recommendation and such stuff. Then there's what we call the general AI, what is they want to build like a system that knows everything. Basically, it's like a human being. It knows everything. So all the specific tasks all brought together, the AI should be able to do that. Then something to keep in mind is that AI is not the end of anything, or the goal is not that, but AI is an enabler. So most of the time you will hear that people are building AI-enabled systems. It's very rare you hear someone saying they're building AI unless you're in academia, where you're actually, even in academia, you won't be building AI, you'll be building something for AI. So that is something to keep in mind when you're actually looking at AI. So now I wanted to now get into a subsection of AI. So there is the computer system bit, which is solved by the software engineers. And then now the machine learning. This is now where the data scientists come into play, where the data scientists and the machine learning come into play, which I do assume this is now where we all fall into. So what we need to know is that machine learning and AI cannot be interchanged. So the way I look at it is AI is a mall, machine learning is a store within the mall, and then deep learning is an aisle inside the machine learning store. So there, you can't interchange them because machine learning is a subsection of AI. Then when you're talking about ML ops, it's when you're taking the machine learning into production. We call it operationalization of it. So most of the people actually, when they do machine learning, they all fall in the notebooks, and you get a CSV plotted to something like pandas, and then you just train a model, and then that's it. You look at the accuracy and it ends there. However, in industry, it starts way, way, way before the CSV. And this is now the subsection of people in the industry of MLOps. So we have the data engineers who digest and process the data. So this is just their main work, is to get the data and to process it. Then there is the data scientist. If you can look at the purple line, the data scientists are the ones who do the model development. So they do the training and the validation of the models. And they can sometimes be in the serving, the model serving. Then you will see there are people who are the application developers. Now, these are the software engineers. They're the ones who consume the model. So once the data scientists have trained the model, they validated the model is okay, then now the software engineers are the ones who come in and they actually consume it. Then if you take data scientist and the software engineer and probably merge their job description, you'll come up with what they call the machine learning engineers. So the machine learning engineers is they make the model, and at the same time they serve the model. Then on top of all that, you now have the business analyst working on top, and you can also have the IT operations. So they are all working on top. So you see, all this is just one model. It is not multiple models. This is just one model. So if your application, let's say, has 3 machine learning models, each will have an instance of this. Sometimes the job of the data engineer will be to put the data. Maybe you want to put the data in a same place. So the data engineers will be the same, but the machine learning engineers might be different for the different applications. Or maybe it depends on the organization, the way they want to structure it. But if you can see the clear, the clear description of the tasks that each and every person actually works in, you'll be able to now understand the tools that are needed. However, in Africa, all this from data engineer all the way to machine learning engineer, people look at it as one person, which actually makes it it's really difficult for someone to actually master the whole thing. It's really, really difficult. And that's why you see people, it's really good to, at least if you're a data engineer, you're a data engineer, if you're a machine learning engineer, you're a machine learning engineer. And then now the researchers come in, they come in with the models themselves, because the data scientists consume, most of them consume this is the data scientists in industry. They consume the models that have been done in academia. However, sometimes they are also data scientist researchers. So they work in the research area. So they're the ones who come up with the actual algorithms. So in this case, is the algorithm, they come up with the algorithms, then they have the machine learning engineers actually code the algorithm that is going to be used in the training. So up to there, I hope it is clear, so that when we now go to the tools, you'll actually have that in the back of your head. So before we actually dig deep into the tools, there's some things that you need to keep in mind when you're actually choosing tools. So number one is, what's your programming language, right? So you have to choose a programming language, whether it's one or whether it's two, depends with how you look at it, but at least you have to have a programming language in mind. Once you have the programming language in mind, it will help you now choose which tools to work with, because some tools are very good in one language and the others are not so good in the other language. So the second thing is open source versus commercial. And in this case, it's more of the company that you're working with. So there are some companies that are very strict and they want open source code. And then there are others that want commercial code. But one thing that I've realized is that some, if not most, of the commercial tools are actually built on top of open source. So someone will take an open source code, then add their flavor into it, so that it's very specific to that organization. And in some cases, it's just they saw a gap in some of the open source tools and they decided to actually just work on that specific. Then the next one is the community or the support. When you're choosing a tool, you have to understand that you need support. So people asking questions, people have answered questions, people facing the same problems as you're facing. So when you're choosing a tool, just make sure that the tool has support and it has a very active support. There are some tools that have a lot of support, but the support is not active. So make sure you have an active support, so that when you face problems, it's easy for you to actually ask and they will help. And also they keep improving. With a good support, it means that they'll keep improving the tool. Then the next one is the tasks covered. Does the tool actually cover the tasks that you're working on? There are some tools, as I said, some tools are very specific to a problem. So you cannot interchange them. So you cannot use one tool to try to solve another tool. You'll be very frustrated. So read the documentation and make sure that it is actually serving the task that you want to work with. The other one is integrating with other tools. There are some tools when you look at them and you want to merge. So you have a data engineer and then you have an ML engineer. And the tool that the data, because all these things actually work under one system. As much as there are different people doing it, is it's one whole system. So if the data engineering tool does not work with the machine learning engineer's tools, there's going to be a problem. So just make sure that they are working well together. Then the other one is a cloud service provider. Does your cloud service provider actually has the tools that you're looking for? So if you're trying to choose, let's say something like, which is the easiest tool that we can work with here. I don't know, maybe TensorFlow. It's a framework. Does AWS have TensorFlow, or does it support TensorFlow? If it does not, then there's a problem. And remember that your cloud service provider is determined by the organization you're working for. So if your organization is clear-cut and they want to use Google or they want to use AWS, this influences the tools that you actually are supposed to be choosing. Then the other one is the flexibility. I added flexibility because this is personal to me. I want a tool that I can be able to build on top. If that tool is it's very fixed, for me it's really a big problem. So that I cannot actually make it work with my solution, actually add on top of it. So the other one is the cost. How much does it cost for you to use that tool? There are some tools that are very expensive, and the organization you're working for will not support, or it's not worth it to actually use it given the tasks that you're actually working with. So how much cost? And this one is also a trade-off between cost and performance. There are some tools that they don't perform really well, but they're okay in the terms of cost. So for you have to actually gauge, when I choose this and the performance, how does it influence? Okay. And then something that I didn't add in the cloud service provider is that most of these cloud service providers have flavors of open source. So if you have something like Apache Kafka, you'll have a flavor of Apache Kafka in AWS, a flavor of Apache Kafka in Azure, and a flavor of Apache Kafka in Google Cloud. And these service providers maintain that flavor, and which is different from the actual main open source code. So you'll have the support, the community for AWS Apache Kafka, the community for Azure Apache Kafka, such stuff. So you have to actually look into it and just gauge the way you want to it, the way they have changed. And something that I realized about these tools, that they can really mess you up, especially if you're working on live code. There's a scenario where we were using an open source tool, and every time they updated, our code will actually break. Every single time they will update, it will break. And it was not breaking because there was a problem with our code. It was breaking because of compatibility. They added something that actually messed up with our code. And so you really need to figure it out in that case. So I can pause up to there if you have any questions. I think I saw a question in the chat. Oh yeah, take a question over there. So I can pause here if you have any question before I actually go to the actual tools. If anyone has questions before I go to the actual tools. Okay, there's none. Okay, let me start. Let me now go to the actual tools. Sorry. Now, data pipeline. So this is where, sorry, I didn't finish that one. This is supposed to be data pipeline and processing. So this is where the data engineers fall. So when you're dealing with data, you first have to get your data, right? You have to get your data into your environment. There are two ways of doing that. There's something called ETL, which is the extract, transform, and load. This is mostly where you do your transformation on the fly. So you transform the data before you put it in your storage. And then we have something that has recently now been used, which we call ELT, which is an extract, you load it, then you transform it once it is in your storage, right? So data can either come in as a stream, or it can come in batches. So stream is basically real-time analysis. So the data is coming in real time, like when you're talking about IoT, when you're talking about tweets, financial data, you're processing financial data and such stuff. So they all come in real time. Then batch processing, in where you're actually analyzing your data in X interval of time, okay? So when you're talking about X interval, it can be you're processing your data in every hour, it can be every single day, it can be after every week, every month, every year, and this actually influences the data that you're supposed to be using. So the ETL, basically, I divided it into data ingestion, data processing, and data storage. So the data ingestion is basically where you're getting the actual data. So AWS has a tool called Kinesis Data Streams. It's supposed to be streams, didn't see that one. Data streams, sorry for that. Then Azure has a tool called Data Factory. So the Data Factory is actually fully managed data integration service for analytics. So it's actually, you can actually load around data from 70 sources. Then there's something we call the PubSub by Google. GCP here is Google Cloud. Then we have, that one is also real time. This is streaming. Then we have one called Stitch. Stitch is not under the cloud service providers. This is different. It's actually, I think, a startup, if I am not wrong. It's quite, I won't say it has been there for so long, but it has been there for some time. This one, you can load data from more than 130 sources into your data warehouse. Okay? And so the Kinesis is serverless. Here, serverless basically means you don't maintain the server. So you don't install you don't create your machines, the virtual machines. So this one just works, and you pay for what you consume. When you're loading, you just pay at that simple time. Then we have the Apache Flume. Flume here is the data transfer tool. This is basically for simple data transfer. So you have your source, you have your channel, and you have your sink. So your sink is the storage. Where are you putting? So where is your source and where are you putting? Then Apache Nifi. This one is open source. Apache Nifi is used to automate the flow between systems. Well, it's very popular, Apache Nifi. Open source, and then you can actually see how you can integrate it with the data processing. Then we have data processing tools, and the most common you'll find out there is Apache Spark. And Apache Spark, there are different flavors depending on your cloud providers. So Spark is for big data, and in big data is when you're talking about data of 1 TB and above. So if you're talking about less than 1 TB, I will advise you not to go with Spark, because it is really, the architecture is quite complex, and it requires a lot of time and resources to actually maintain the infrastructure. So Spark is used for really, really big data, and it's really good. And the reason why it is good is because you actually load your data on memory, and then you now do your processing on memory, and it makes it really, really fast. Then we have one which is called DBT, which is data build tools. So DBT, when you don't require Spark, meaning your data is really small, you will go with DBT. DBT basically is you transform your data when it's in the warehouse. So DBT is just simply a tool. The processing of the data will actually be done in your data warehouse. So an example is actually DBT, you only write SQL codes, the SQL queries. And then once you write the SQL queries, the actual processing will be done in your data warehouse. And the reason why it is good is because of its version control. So with DBT, look at it as you're writing your code and you're versioning. You're writing your SQL statements and you're versioning your SQL statements. Then we have the data flow, GCP data flow. Same case in the processing. Then the alternative for AWS for doing processing is Amazon Kinesis data firehose. So this one does, once you extract your data, it goes through the firehose, and you actually it does the processing at that point. Also streaming, it works with streaming. Then we have what we call Apache Flink, also used for processing. And then one of the famous or very, very commonly used for processing streaming data is Apache Kafka. So Kafka is used for, let's say, complex microservices. It's more of a messaging or an event-driven solution. So when you have your different, instead of having API, when you're having API calls, you'll use Apache Kafka, and Kafka will actually, you can do your processing within Kafka. And Kafka is actually blended with many things. You can blend it with Flume, you can blend it with Spark, you can blend it with a lot of things. We also have Apache Storm. Storm is also for stream processing. So as you can see, there was a big gap when it came to the streaming bit. Once you have data that is being processed after a period of time, so you're taking batches and processing after a period of time, there were already existing solutions. But the problem was, you can see most of the tools are actually being done. They're actually produced for streaming, because streaming is really a big deal. How do you process your data, and it's supposed to be given in real time? If you're getting transactional data, how do I convert it to something different, or how do I transform it to something different and actually give the consumer an output at the same time, at that particular real time? So processing the streaming data was actually a big, but there are a lot of tools to actually work with. Then the final, once you've done the processing, you put them into the storage. So storage, there are two types of storage. And this, the reason I put this as this storage, this the your DB kind of storage, no, leave that alone. So this, we are talking about the big data storage. So you can either put it in a data lake. So a lake doesn't have schema. Look at it as just a place where you just dump everything. You can dump anything, a lot of different file formats you can be put there. You can put text, you can put images, you can put CSVs, you can put everything you can put over there. An example of lakes is tools for the data lake is S3 bucket. You actually can have Azure blobs, same thing, GCP data storage, and then you can also have Hadoop over there as part of the data lakes. And the most important thing about your lake is to make sure that you've stored your metadata, right? So the data, you actually understand that you have the metadata of the data that you're having. If you don't have that, you'll have a problem with actually sorting out your data. And from a data scientist, most of the data scientists pick their raw data from the data lakes. So they don't want, most of the cases, they don't want people to actually do the transformation for them. They just want their data in raw format, then they come and work the way they want. They do their work the way they want from there. But the data business intelligence team and the data analysts, most of them want the data transformed. So you'll find people doing the transformation of data, and then the business intelligence team will come and now plug in their visualizations from that side. Then we also have data warehouses. Now warehouses have schemas. These ones more or less look like relational data, the relational data. So examples are BigQuery for GCP. BigQuery is serverless. We have Azure Synapse, also serverless. We have AWS Redshift, and then we also have Snowflake. So these are data warehouses, and you can do all your manipulation on data warehouses, in the data warehouses. So DBT mostly connects to the data warehouses, and you do whatever you want with your data warehouses. Apache Spark, on the other hand, it connects to the data lakes, and you work like that. So once you've done with the data pipeline, so this is mostly, and this is not an exhaustive list. There's a lot more, but we can't put them all over here. There's a lot more tools that you can use, but these are just some of the commonly used examples. After that, now you move to model development. So I used this basically because model development has a lot of subparts, okay? And so getting all the tools under one table was actually a little bit of a big deal, but I will try to explain. I got this chart from one of the people who have been doing research on MLOps tools. I have the reference in the, I have the link in the references. And she went and did a research on the tools, went and looked deeply into them and categorized them, which was really, really fun to work with. So you'll have the frameworks, which these are the PyTorch, the TensorFlow, the Theanos, the Cafe, which one is the other one? The JAX. Those are frameworks that you actually use. Then there is so when you're actually doing the actual data model training, you can use these frameworks for your model, and mostly it's deep learning. You also have skitlearn for the traditional machine learning. You have your notebooks, the Jupyter and the Colab, which is basically just Jupyter put in really well. What else do you have? You can also code in your IDEs when you're doing data development. You can code in your IDEs. So this is just a list because this is during development. So development, what do? You already have your data. So you put your data somewhere where you can consume them and pass them through your training of your data and the validation of your data. So these are just the sum of the tools that you can use it. In terms of the service provider, Google has Colab. Azure has machine learning studios where you can actually, so instead of you coding from your machine, because in production, the data is a lot. So you really need a powerful machine. Now for AWS is something we call SageMaker. So all these actually help. And then something to just keep in mind when you're doing your development is that when you're doing training of your data, you need GPUs. So you also need to look at the availability of the machines to actually train your data. So, and I believe all three of the service provider have good, but the prices they're more or less close to each other, but you can actually just look at them and judge in terms of cost. And now to just, it's up to you now to choose where you want. So also the tools are also determined by your task. So there are some that are very good in very specific tasks. Like there are some tools that are very good in computer vision. There are some tools that are very specific to NLP. We'll find your SPACY, your RASA and all that in NLP. So you just need to look at the different tools and just to make sure that they serve the task that you're actually working on. And then finally, once you've done your development, it now needs the serving. So serving basically means is how will your consumers consume what you've done. So you've gone through the whole place of you're getting the data, you've done your development. Now it's up to you now to do the consumption, how will you serve it to your customers. And in most cases, the serving is done through APIs. You'll find people who do the serving through API. So someone just writes a simple Flask API and actually just connect it to it. For demos, this works. However, for a long time, when you're talking about production, you need to monitor your model and you need to version your model because there's something called the model decay. When you use a model for some time, it now starts, the accuracy starts going down and you need to monitor and you make sure that as it is going down, you're actually tracing it. That's number one. The two is how are your consumers consuming it? Are they consuming it on edge devices? These are the devices are outside the cloud. So these are on actual gadgets, or are they consuming it via mobile phones? So all this determine how you're going to serve. And this is just a simple list of some of the tools that you can use. You have the TensorFlow serving for TensorFlow models. Then there's Gradio. Gradio is very good, actually. It's just an app interface. It helps you once you've had your model, you can use Gradio just for people to actually play around with your model. You have the Torch serving. This is for PyTorch models. KEF is basically for Kubernetes. When you have your model under Kubernetes, you can use it for serving. Then you have, Seldom. Seldom basically makes it easier for you to deploy your models on Kubernetes. So if you don't want to go straight to Kubernetes and play around with Kubernetes, you can use Seldom to do that. Then you have the Core ML Kit, and the TensorFlow Lite, and also NCNN. All these are for mobile. So if you're putting your models on mobile, you know they have to be compressed. they have to be actually mobile friendly, so that because most of the time they are actually on the device. Then NVIDIA has the Tensor RC. It's very specific to NVIDIA. We have Formant. This is for robotics, anything to do with robotics. Then the last three are basically for monitoring. These are just tools that you can use for monitoring your models. So it will look at the decay and the versioning and all those things. Then in some of the tools, I call them the others, which work hand in hand. You will have what we call workflow orchestration. Workflow orchestration is, you see the way the data comes in, it is not a one-off. If it's always continuous streaming, you need something which will actually take your data to automate the whole process of taking your data from your source, processing that data, taking that data to your model, training the model, validating the model, putting it in. You can put your model in a storage. It can be a data lake or something of that sort. Then you'll have once it has put it over there, you have to repeat that process. How many times do you need to retrain your model? So you can use that to actually schedule all those. So that whole flow, there's someone who needs to actually conduct the whole process. And so some of the orchestration tools, the one that I've used is Airflow. There is Luigi and there's Prefect, although there are others which you can actually use. And then there's also the versioning, which is really, really, really important. There's a GitHub, you can version. So depending on where you are at, you can do your versioning using GitHub, you can use using GitLab. For data, many people don't know that you can actually version your data. So DVC is data versioning. So it does the versioning of your data. Then there's something called the DAG Hub, also does versioning for you. Although also some of the other tools in here and not serving and under serving, they also do the versioning of your tool. They come in with versioning in play. So yeah, so they come in versioning. So we've gone through the whole process of from the time you get your data to the time you do the development of your data, to the time you've served your data and all the tools that are there. And then now finally the others, which is in the orchestration and the versioning. And I guess that's it. And with that, you'll be able to complete. So I did not get into software engineering because software engineering is a whole different use case where you just plug in the models. But this one will actually help with that. So I will stop there and for questions that you can ask.
Thank you so much, Yvonne. This was really insightful. Actually, this was a lot to carry in. I thought I knew a lot, but with what you've said, I feel like I need to go back and do a lot of reading myself. I saw a question, so we'll just move straight to the questions.
Yeah.
Someone asked, what advantages does ETL have over ETL? Or
ELT.
ELT. Sorry.
So ELT is mostly for doing data analysis. This is where we're talking about the business side, the marketing side, and you're talking about the operational side. So all those guys in business side, ELT really helps them because you load the data. They don't need the data like right now. The ETL, on the other hand, wait a minute, no, I've confused it. ETL, the transformation, it depends with the tools that you're actually using and the data that you have, and do you really need it at the right at the moment. It's all about the streaming and the batch. So for the batch, you'd rather load it and then transform it later, and then the other one you can transform it. So it depends with the tools that you're actually using, and it also depends with how much data you have. So if you have a lot of data, doing the transformation on the fly is actually, it might be a problem. However, if the data, if you're using streaming data and you really need to do the transformation at that point, then it works. I don't know if I've confused you. But on my side, basically, you can simply say it's more or less on the streaming and the batch. That's just how you look at it for simplicity's sake. So the streaming and the batch, in the batch cases, yeah.
So that is your question answered. Okay, so my personal question would be, how do you know the tools to choose for which for a particular task?
It boils down to just these questions that I had over here on choosing your tools. So in some cases, you'll get into a team that has already been using specific tools. So you don't have a choice but to use that tool, right? And in some cases, if you're the lead, look at these things. Look at your team. Which programming languages are they using? So they're using Python or they are using R. Then you go again and look at what in your organization, do you have the money to pay for some of these tools? And you know, when you're going to pay, just make sure that you read this tool. There's no way you can actually do whatever you're trying to do other than doing it through open source. Other than actually buying this tool. If whatever you're trying to achieve can be done by an open source tool, then we always choose the open source tool. And then with the open source tools, there's so many open source tools solving the same problem, right? Now, it all boils down to the community. This community is very, very important. If the community is a big community and is also a very active community, meaning they're actually adding releases, a release after release, and they're listening to you, the developer. I want X to be added to this tool. You put it on GitHub, and these guys go and put it over there. So that's all. Then the task, which task are you using? And then just look at if you're using any cloud, look at the cloud. And then now choose the cost in terms of cost. And also, if all this is still confusing, just go and look at what problem are you trying to solve. Then look at what most people are actually using, and that will actually help you choose the tools. And then you can stick with one tool. If it solves your problem, then the more you use the tool, the more you will see the gap, right? And then once you see the gap, you'll be then if this tool is actually not doing this, let me go and look for something that actually has been actually solved the problem that this other tool is not solving. So that's the way personally I look into it. I just choose what are people looking at, then go and look at the pros and cons of that specific tool. And if the cons are I'm okay with the cons, I just start. Then once you get somewhere, you'll now be able to know, then let me choose something different. Yeah.
Wow. So then someone says, just to follow up on the same slide, there seems to be a lot of available tools for a particular task. So for beginners, what will you advise? What's
simplest?
Yeah.
The simplest.
The simplest.
Look at the simplest. Pick the simplest tool, because remember the tool is actually example, I've been working on a lot of data engineering tool. So the data engineering tool. So basically the data pipeline, I've been working a lot in that case. So there are a lot, and you'll be really tempted to go for, the big companies are using this, but remember you're in Africa, right? And there's the data that is being consumed is not a lot unless your organization is very mature. So if it's very mature, it means it has a lot of data, it has the data policies and all those things. But for you as a beginner, look for the simplest tool that will help you understand the basics of the data pipeline. And the basic of a data pipeline is to move data from one end to the other. Be able to move from data from one end to the other automatically. If you can be able to code that using the simplest tool, that one will give you the basics. Then you now start advancing. When a problem comes in, you know the basics. When you move to machine learning, the ML engineering, look for the tool that will actually help you achieve the basics of machine learning engineer. If they can help you with that, you actually grasp the concept. Then now you improve. So you just start with grasp the concept, which is the tool that will help you actually grasp the concept. the simplest, and then now move up.
Okay. So on the same question, which is the simplest? What does this simple, what does being in a tool? Yeah.
Okay, so maybe you can ask her from a specific, because there are different tasks. Just maybe you can say which task you're looking at, then I can tell you the specific tool.
Okay, this was the question from the comments.
Data integration. So with data integration, the simplest that I saw was using Airflow for data integration or ingestion. Basically, either way. So the data pipeline, the easiest that I saw was Airflow, and just simply Airflow will help you do the pipelines, right? So from moving from one step to the other, I used Airflow, and then I used simple Python code, because I use Python. So if you're using Python, it's simple Python code. If you're getting an API, you'll just use a simple API. That one will be there. So just code your API, and then Airflow will help you orchestrate the whole thing, meaning automate the whole process, so that the next time, if you're taking your data every, let's say every week, you just code once, you upload it to wherever you're uploading it, and then it comes in, runs your code every now and then, runs your code every now and then. So in terms of ingestion, basically we are talking, ingestion is basically Airflow. For me, I used Airflow. That was the simplest tool for me. Okay. But it all depends. It all depends. As I said, it depends with the task itself. And the task here is also the problem you're solving. How is the data coming in? So in such cases, I will tell you, avoid the consumer tools first. Avoid the AWS, Azure, and the GCP first. Look at the others that are not related to the consumer, to the cloud service providers first, and then after that, now go to the once you've mastered the whole process, now go to the cloud providers.
Well, thank you so much. I hope your question is answered. Then the next question is, what data processing and streaming tools can we use in robotics? So I'm sure the person is working in robotics and wants some tools to use.
So all these, most of this, so this is it. Let's see, I'm going to go back to that question again. So it's the data processing, right?
Yep.
Data processing, yeah. So it's processing, there are a lot in terms of processing the data. So you'll have, if your data is really, so this is IoT. If you're doing robotics, can be IoT, can be also other events. So you can use Kafka in combination with Spark if it is a lot. Kafka in combination with Spark if it's a lot. You can also use Storm. Storm can actually also help you in that case. So you can try it out. Storm can help you in that. I've seen people using Storm, and I've seen people using Flink. So you can try, if you're a little bit advanced, you can try and see how the different service providers, the cloud service providers, they have specific for that specific area in robotics. They have tools specifically for that. So you can try and use it. But if it's just general, you can, and you're starting off, you can try Storm, you can try Kafka, and see if you can combine it with Spark and try to see how that works. That one will try and help you. And then after that, you can now start building, because I haven't done much in terms of robotics, so I am not quite sure how the data looks like. But if it's an advice on just which tools to pick, you can start from there, then now see how it does and if it's solving your problem.
Oh, very, very, very dense, I must.
Yeah. So the thing is this, you don't need to master all these tools. Pick one. In it, if you're in data engineering, if you are in the data creating data pipeline, just pick one and stick to it. If in the processing, pick one, stick to it. If it's the storage, pick one, stick to it. If you're doing anything to do with data science, just pick one, stick to it. So all these are just different tools. and you don't need to learn all the tools because most of the time they do the same thing. So it's just for you to pick one and then just stick to it, learn it, and stick to it. And also look at, when you're looking at the job descriptions, one way I've seen is I've gone to JD of different organizations in the different jobs that are there. So if you're a machine learning engineer, just go and peruse and see what are the companies requiring. You'll see people who are saying, like the data engineering, most of them are Spark. You need to know Spark, you need to do SQL. In machine learning, you'll see people will say you need to know PyTorch. Other guys will be like, no, as you are TensorFlow, so you need to know TensorFlow. So you need to understand what people are actually looking for, and then now for you start working on it.
Thank you so much, Yvonne.
Yeah.
If anybody has any more questions, now will be the time to ask because we are almost getting to the end. So there's I think there's another question. At what point can someone consider himself or herself an AI expert?
I can't say there's an expert. You can't be an AI expert unless you can be an expert in a very, very specific area of AI. And given that it keeps changing every single time, it's just master. For me, I always say you just master a particular sector, master it and stick with it. And if you do it over and over again, you'll encounter different problems. So the first project that you're going to do will have its own sorts of problems and that you'll be solving. And when you go to the second task that you're going to be doing, or the second project, you realize that it's just a build-up. In some cases, you will already have learned what you have learned, but in some cases, you'll have things are new. So because the problems keeps changing and you keep encountering different problems, then unless you really have lots and lots of projects that you've actually worked on, at the time you'll start saying you're an expert. The time now you'll start saying, by the way, I know this, I've already done this, I've already done this, I've already done this. So it's all in terms of projects. But because the problems keep adding up and adding up and adding up, it becomes an issue.
Okay, so another question. May I kindly know which part of Africa our speakers comes from? Let me see if my guess is as right. Okay.
I say I'm from East Africa, Kenya. I live in Kenya, but I work in Rwanda, Kigali. That's where my company is at.
Okay, that was actually a nice question.
Yeah.
And an interesting one.
Yeah.
So any more questions for Yvonne? Because our time is almost up. We have about 5 minutes more to go.
So I guess when we're just basically waiting for the other questions. So my final advice would be this. Pick a tool, start learning it, and document it through blogs. And that one is really, really important. When you document it through blogs, it helps you actually see that you've actually understood and actually help others in the same case. And when people start responding, and when you see people following you, when you go to their own blogs, you'll be able to actually see also them and what they're actually doing, and you can actually be able to interact. So just pick a tool, start. The thing is just pick a tool and start. You can never go wrong because the tools that have communities, they're there for a reason. So just pick a tool that is actually solving your problem and learn it. And then now you go to the next, if something within the problem is not being solved, go and look for another tool or actually develop your own. So that's how I just do it. Pick a tool, solve your problem, master it, do a lot of projects. It's not just learning, you do projects with it. And once you do project, you'll be able to understand the inside and out of the tool. Yeah.
Thank you so much. I have actually taken this advice. I'm going to do a lot of projects to master my data science skills.
Yeah.
To be a master in the skills, actually. So I think that there are no more questions. And I would like to say a very big thank you to you for making it to today's event. And I know that everybody or each person here is taking just took something, a note from what you discussed. So kindly, please follow us on our social media platforms. We have Twitter, so you can follow WiMLDS Accra chapter on Twitter. You can also join our Meetup pages. Maybe any of the organizers could put a link of that into the chat for me. Thank you so much. If you also have any questions for Yvonne later, maybe you come across this video and you want to you have some questions to ask, you can also send us a chat through our Twitter platform, and we will respond. Also, Yvonne, do you have any social media platforms that you would want to share, or you would want people to reach you there in case they have further questions?
Professionally, I'm very active on LinkedIn. So I guess my LinkedIn is, I think it's just Yvonne Wambui. I think the whole LinkedIn and just Yvonne Wambui, that one you'll find it. So that's where I post most of my informations, yeah, and the tools, yeah.
Also, the links to our social media platforms have been put there in the chat. Do follow us for more of this. Thank you so much for joining us, everyone. And for now, I'd just like to say have a good evening from my side. And thank you for making it.